Okay, so on the first one it says condense into a single logarithm. Do you guys remember what to do? Remember what it's asking? We do need to combine the logarithms into one logarithm. Okay, so do you remember what to do with the 5? Where does that 5 need to go? A number in the front needs to move back as a, okay, as a power. Go to the back as a power. So everyone do that with me. Okay, so that's v to the 5th. Now, I heard someone say that we have to divide. Why? Because two logarithms are separated by subtraction, right? And here's what I know. I know that log of m minus log of n is log m over n. So when I'm doing this, I've got log base 2 of what? U over v to the 5th power. And there we go. Okay, so we're going to do the odds today. Okay, so let's go to number 3. Alright, so what would you do with the 8? Move it to the back. What would you do with the 2? Alright. So I've got log base 7 of u to the 8th minus log base 7 of v to the 2nd. Now you don't have to do this step if you already know what to do. I'm going to combine them into one log, say log base 7 of. Okay. So I say the first one, right? U to the 8th divided by v to the 2nd. And we're done, right? Okay, so this right here is combining. This right here is what? So doing the exact opposite of what we just did. Okay? So now these are combined using multiplication. How do I separate them? Because I know that log of m times n is the same thing as log of m plus log of n. Okay? So I'm going to say log base 7 of z to the 3rd. Okay, and we'll do that in a second. Good. Now what do I do? What? Plus. Good. Do I do another log? Log base 7 of w to the 1/2. Okay. Now, just like over here, the start of the problem had the powers in the front, so we should put the powers in the front as well. So this 3 should go to the front, so it should be 3 log base 7 of z. And what? 1/2. Yeah, you'll miss that last little point. Okay, but remember, you've got basically a clue right here. If this has a number in the front, then your final answer of this should have the number in the front. Because all you're doing is going exactly backwards. Okay. Do you think I should do anything with this power 4 first? Distribute my power 4? Okay. So I'm going to distribute that to that, to that, and to that. So I'm going to rewrite it. Log base 3 of u to the what? V to the 8 and w to the 4. Are these multiplied or divided? They're multiplied, so 3 logarithms, good. I'm going to have 3 logs. They're all log base 3. Are they all separated by addition? Okay. What should go in the front of this first one? The power of u. So I'm going to put 4 here and put what here? U. Well, I'm going to go ahead and go straight to the answer. See right here? No, you got to put the power of the front. Nope. So now what do I got to put the front here? 8 with the, and then what here? With the, okay, and there we go. We good? Alright. Alright. Okay. Okay, so guys, do you guys remember graphing natural log functions? been a couple days. So here's what I'm going to do. I'm going to just in general go over natural log. Okay, y equals natural log of x. I don't know if you remember it, but it's the function that crosses at 1 and does this number. Do you remember doing those? We have a vertical asymptote at x equals 0. Okay. And then I could plot points and make sure that I got the whole graph, right? Okay, so what happens whenever I do something like natural log of x plus 6 minus 3? I'm transforming the function, right? Okay, so let's remind ourselves. F of x plus 1, f of x minus 1, f of x plus 1, f of x minus 1. On the inside, if you plus, where you go? Where do you go? To the left. Here you go. To the right. Here you go. And here you go. Down. Good. Okay, so using that, let's talk about this problem right here. Which way are we going, guys? Okay, so I expect us all to write to the left 6 and then down 3. So here's what I know. I know normally the graph looks like this, right? But if I move it to the left 6, that vertical asymptote goes to what? To the left 6. Okay, so I'm going to go over here to negative 6 and draw my vertical asymptote. Okay, so I've got a vertical asymptote at negative 6. Yeah? Now, from here, what we can do is we can take our chart, or take our calculator, plug it in, and plot some y values, okay? So, natural log. Where's natural log on here? Right there. Okay? Side the 4. So natural log of x plus 6. And then what? Minus 3? Okay. So I've typed it in. I'll go to my table. Okay, now notice how when you look at your table, negative 6 on says error, right? Which is why it's that's my vertical asymptote, okay? So the first point that I see is negative 5, negative 3, right? Okay, so let's plot that point, guys. Plot the point negative 5, negative 3. You need one of these, Skylar. Skylar, you need one of these. Okay, so let's plot the point negative 5, negative 3. I'm going to go to negative 5, negative 3, and plot my point. Now, what's the next point? Well, did you not type it in your own? So y'all are lazy. Negative 4, negative 2.3. So at negative 4, negative 2.3, which is somewhere around here. And then negative 3, negative 1.9. Negative 2, negative 1.6. Negative 1, negative 1.39. So it looks like it's just slowly increasing, right? If I wanted to, I could... Nah, that's good enough, right? Okay, so I know it does this, but is that the only piece of my graph? What happens over here? Okay, so it goes right there. Alright, and there's my vertical asymptote. Good. So if I asked you, you could say vertical asymptote at x equals, what was that? Negative 6. What about domain and range? Well, what's the farthest to the left this function goes? Does it actually reach it? So what do we put? Parenthesis. And then I go to infinity, right? Why is range all real numbers? So since range is y, it goes all the way down and all the way up, even though it takes a really long time. So we say all real numbers. Okay? Alright, now the rest is solving equations, basically what we've done for the past few days. So, let's just go through it and see what we can do. Okay, so if I've got 20 to the x equals 74, this is an exponential form, right? What are you going to do to solve it? Right, so let's do logs and stuff. Let's put it in log form. So log base what? Of equals. Okay. Do you have to type it in or can you be done with that? You can be done with that. Okay. Alright, so let's talk about 13. Alright, what do you want to do? Add 6. Okay, so 5 to the k equals 7. Now, is this the same situation we were just in? Okay, so what do you want to do? Okay, so log. Okay, base 5. And there you go. We're done? It's being raised to the power. Okay, yeah. Okay, can you guys remind me what gets rid of e? ln. So what would you do? Right, and I'm going to put it in the front, right? Okay, so now what happens with natural log and e? Good, so what am I left with? Equals the natural log of 44. How do I get rid of a negative 7? Okay, so a equals the natural log of 44 divided by negative 7. And that's all I have to do, right? Sorry. Okay, so what about 17? Okay, 17 is where we use the power chart. Here's what I know. I know 64 is a power of what? 2? And it's a power of 8, right? And it's a power of 4. But 64 and 8, well, I guess you could do 8 and 2. I don't care. Which one would you rather do? Okay, I'll do it both ways. Here's what I know. 64 is 2 to the what power? 2 to the 6. So what I could do is I could say, let this be 2 to the 6 to the 2r plus 1. What is 8? 2 to the what? 2 to the third? So I could say this is 1 over 2 to the third to the negative 2r. How do I move this 2 to the third up to the top? What do I do to its power? Well, first, the only way I can move a power up to the top is to make it negative. So here's what I would say. 2 to the, now, I'm going to work with this side for a second. What do we do with those? Distribute, right. I'm going to multiply. Plus 6. So 2 to the 12r plus 6 equals, so what I do is I'm going to bring this up and make the power negative. So 2 to the negative 3 to the negative 2r. Right? At this point, these powers, I just multiply them, right? What's a negative 6 times a negative 2r? Okay. So what do I do when I have 2 to this equals 2 to that? Just to say what these were when I multiply. Right? So if I have 2 to the 12r plus 6 equals 2 to the 6r, then I can just cancel out the bases and solve that equation, right? Okay. So 12r plus 6 equals 6r. What would you do? Add the r's? How? Subtract 12r? So I'm left with 6 equals 6 minus 12 is negative 6, so negative 6r. And there we go. That's it. That's It's my mission in life. Mm-hmm. Yep, so that was the answer. R equals negative, or R equals negative 1. Okay, guys, I'm going to give you a second. I want you to work this next one. You can go ahead and talk about it. See what you think. I wanted you to talk with your neighbor. Well, talk with your neighbor, see if you guys agree. And do it. Austin, what are you doing? To solve, what would you do? Okay, and then... Okay, so you're saying I can just cancel those out? Yep. So then, Austin, what would you do to solve? You could add 9. So you got negative 4x plus 10 equals x. What would you do now? Don't you want to get this x over there? Plus 4x. So 10 equals 5x. So then what do I do? And I get? Alright, bless you. Well, you know how I said you have to make sure that you don't have log of a negative number? Because remember, logarithms don't exist on the negative side. Not unless they're shifted. When you plug in a 2, what's 2 minus 9? Negative 7. Does that exist? If you want to make sure, log base 17, alpha window, log base 17 of negative 7. Doesn't work. You just have to make sure that when you put, and yesterday we didn't have any that actually did that. Well, you just might need to think about that whenever you plug it in. If I get log of a negative number, it doesn't exist. Now, guys, if you just left it as 2, you'd get there would only be a last little half point for checking. Okay, anytime you have a logarithmic equation, if you have an answer such that when you plug it in you get a log of a negative number, then it's not a solution. Okay? So we'll see if any others show up. If they don't, then we'll be good, okay? If I put 1 on the test, there'd only be 1. So you just have to think about plugging that in. Okay, so what about this one? Same thing? Okay, so I'm going to cancel that out. Okay, guys, this is an x squared. You know what that means I want to do? Well, I can't because there's an x. I want to get everything on the same side, and I want to solve it like a quadratic, either factoring or a quadratic formula. I probably don't have to do that, but we'll see. Okay, so I want to keep the x squared positive, so I'm going to move this over. And I'm going to move this over, okay? So we're going to subtract 13x and subtract 1. I'm going to get everything on the same side. So what I'm left with is x squared. I'm going to write the negative 13x next because it's next in order. And then what's 37 minus 1? Equals 0. Okay. Now, I'm hoping this factors. Okay, so how did you figure it out? Did you start doing factors of 36? Okay, so if you start dividing out 36, we're looking for factors of 36 that add up to negative 13. And you get 4 and 9. So if they're both what? Negative, then they'll add up to negative 13 and multiply to give me 36, right? So I'm going to write x minus 4, x minus 9 equals 0. So what are my answers? 4 and 9. Okay, so just as a reminder, if any of these, when I plug them in, give me a negative inside a log, then they don't work. But look at that. That's 13. That's a positive 13. X plus 1. These are both positive numbers, so when I plug them in, do they stay positive? Yeah. Right, and then anything squared is positive. So these are both my answers. Okay. All right, so let's go to 23. What are we thinking? Well, this is inside the log, and that's not, right? So I'm thinking I'm just going to move it. Okay. So if we have a log equal to a number, so if you look over the whiteboard, right there, I'm pointing at it, what does it say? You have log equal to a number. Convert to, convert to an exponential. So if you have log equals a number, convert to an exponential. So what would you do? 9 to the equals n minus 8. Okay. Well, you got to solve for n. So what do? Add 8. N to the negative 1 plus 8 equals n. 9 to the negative 1. Could you type that in to find the final answer? Good. 9 raised to the negative 1 and then plus 8. 8 point. You missed a 1. Okay, so n equals 8.11. Or 1 repeating, right? If you left it as that would be correct. No. Okay, so what do I do here? Right, because now where I'm pointing, right there, it says if I have log plus and minus another log equals a number, I need to combine the logs, right? And then convert. What? Yes, it did. It's actually right, it's purple. But I like changing colors. Okay, so log base 2 of what? Perfect, thank you. Alright, log equals number, what should you do? Convert to exponential. Remember, log equals a number? If you have one log equals a number, convert to an exponential. So what? 2 to the second equals x plus 1 over 5. What is 2 squared? So 4, well, I convert it to an exponential. 2 to the second equals all that. Okay. So x plus 1 over 5. Now, what would you guys do to the 5? Exactly. Well, they're actually the same thing. But she's right. You either multiply both sides by 5 or cross multiply. It ends up with the same thing. So I've got 20 equals x plus 1. So what's my answer? 5 times 4? Okay. So minus 1 from both sides, and x equals 19. When I plug in 19, do I get log of a positive number? 19 plus 1 is positive, so I'm good. All right. Now what shall we do? Combine those logs on the left-hand side? Perfect. So I'm going to combine these two. Log base 8 of 6 over x. Cancel out the logs? But I can't cancel them out right here, right? Okay, be careful, because some people do that. Don't cancel them out till you have one logarithm equals another log. So logs cancel out. 6 over x equals 2 times by x on both sides. So I'm good with that. So, good. Divide by 2. X equals 3. Now, does anyone realize that we could have just switched those two? 6 over 2 equals x. That's what I said yesterday. Alright. Alright, what do we do? Log base 3 of equals. Okay, so I'm making sure everyone's with me. Oh. Okay. But I am. Well, we could watch it. Exactly. See, whatever's in the denominator, that's what we're going to multiply by. So I'm going to multiply by x minus 10 here and by x minus 10 there. Not quite. Okay. Now what do I do? So I got 6 28 times x minus 10. So what would you do with the 28? Distribute it? Good. So I've got 6 equals minus 280. Okay. So I'm going to add 280. Let's cancel out. What's 6 plus 280? You're not good at math, Brock. What did you do? So 286 divided by 28? Okay. And there we go. There's the odds.